So welcome everyone. This is Rona Rothenberg. I'm the VP of Government Relations of AIA California. We thank you for joining us for the fourth chapter of the AIA California Climate Action webinar series, SolarSkyrise, Unlock the Value of Vertical Real Estate. I'm excited for this opportunity to introduce one of our AIA California's partners, SolarSkyrise. They've recently partnered with AIA California Climate Action webinar series, Design for Energy. As you might know, this webinar series is centered around each of the pillars of the AIA's National Framework for Design Excellence. We all know that design is not just about aesthetics, it's about how buildings perform for people, and that includes the people that own and operate the buildings. The Framework for Design Excellence is made up of 10 measures, formerly known as the COTE Top 10, Committee on the Environment Top 10. It organizes our thinking, facilitates conversations with our clients and communities we serve, and sets meaningful goals and targets for climate action. More information on the next chapter of AIA Climate Action webinar series can be found on the AIA California website. So today, SolarSkyrise, and thank you all, you'll be sharing their design tool for architects that makes it possible to analyze the energy potential and business case, the cost-benefit case, for solar on all surfaces of a building with just one click. Their technology helps design for sustainability and resilience and gets closer to the 2030 goal of net zero energy architecture. So just a bit of housekeeping, using the Q&A box. So please use the Q&A box. If you haven't used this tool, just wave your cursor on the bottom and it should pop up. And add your questions to Q&A. If you accidentally look at chat, we'll look at that too, but we prefer them in Q&A. We are recording, so if you're not, we have all of the attendees muted, and then we have our speakers and another participant for the Q&A session, and we will read your questions as they come in. We won't be unmuting you. Each presenter will share a little bit about themselves, and we will be hearing from Elisa Kranis, Scott Russell, and Mark Manzik. And please take it away.
All right. Hello, everyone. And thank you for coming to our webinar. I know that you all have been living on Zoom for the past 8 weeks, so we'll try to make this as engaging and as interactive of a session as possible. We'll do very brief introductions, tell you who we are and why we've developed our product. Then we'll run through a technology demo on a landmark building and open the room for questions. So just a second here while I set up my screen. Okay. With that, I'll quickly introduce our speakers today. My name is Elisa Kranis. I'm a co-founder of SolarSkyrise. I'm an urban planner with many years of experience in the renewable energy consulting space. Our next speaker is Scott Russell, co-founder and CEO of SolarSkyrise. Scott's background is in business operations, and like all of us, he comes with extensive energy consulting background. And our third speaker is Mark Manzik, a co-founder and a CTO. Mark is a technology expert with a long resume of energy sector projects. He used to manage a large international power utility and deliver new technology programs to cities and countries all over the world. We also have our engineering, financial, and software team in the Zoom room to answer your questions as they come up. So let's get started. We live in the era of energy transition. The world is moving away from fossil fuels and switching to renewables. This also means urban energy transition and the shift in the way we plan, design, and build our cities. We have aggressive carbon goals to reach over the next decade. So the way we think about integrating renewables into building design has to change as well. We all know that buildings represent a huge problem. Buildings are responsible for the lion's share of global greenhouse gas emissions, and unfortunately, none of the large cities in the US are currently on track to meet the UN climate goals of 2050. Rooftop solar is a known solution, but it only works for smaller buildings. For taller buildings with large vertical footprints, small rooftop solar is insufficient and is not always the best use of a rooftop, which could be used as a green space. Now, resilience is becoming more critical than ever, and not just for critical care facilities, but also across the real estate sector. Putting the pandemic aside, we're now preparing for the next wave of earthquakes in California, which would likely cause grid failures. Being able to self-generate power will be key, so resilience for building owners is now a top priority. It's great that many of the states and cities have set out aggressive net zero energy targets. Good examples are Title 24 in California, Local Law 97 in New York City. The question is, how do we get there? And what technologies and approaches could be used to realize these goals? In most large urban centers, over 65% of real estate density is vertical and will continue to develop as vertical. That's why we see it as critical to unlock the potential of the vertical space and put it to use. Building surfaces are able to generate clean energy through architectural solar applications, also known as building integrated PV. So what does that mean for the end user, for building owners? For building owners, clean energy translates into emissions offsets, increased resilience, and new revenue streams that come from energy savings and tax incentives. And of course, all of the above translates into reduced operational carbon, and in many cases, reduced embodied carbon. There is a wide range of architectural solar products on the market today. They replace traditional construction materials and can be applied to any part of the building, including windows, facades, skylights. The materials range from fully transparent to opaque, which determines their generation efficiency. The opacity and transparency also dictate how you would use these materials. So even though fully transparent PV window glass has lower efficiency than, say, an opaque spandrel glass, it can be used very effectively in a historic retrofit or an adaptive reuse project where you can't make any design changes to the facade. So here you'll be looking to replace the windows with PV glass, and we'll show you in our demo how we approach these types of window retrofits in our projects. And I'd also like to point out that the OEMs, the companies that make solar products, are now starting to evolve and develop locally in the US. In the past, architectural solar products used to come from Europe, but now we have a number of companies in California, like Walters and Wolf and Next Energy, designing and manufacturing locally. So as you start to look at sourcing of these technologies and consider the embodied carbon factors, it is important to keep in mind that we have a local supply chain here in the US and in California. There are many BIPV projects around the world, but I wanted to again draw your attention to the projects we have here in the US. Some of you who are in LA will recognize the image of the Epic Tower in Hollywood. That's the image on the bottom of the slide. This building was designed by Gensler Architects and features 300 BIPV modules on 2 of its facades. This building is an important industry milestone as it has gone through a very elaborate permitting and code revision process to approve PV on the facades. But the process is now in place and it will allow for future projects to move forward. So these projects are a living proof of the technology, but why is it still novel to the design industry and why is it so difficult to model these projects? Analyzing vertical surfaces is far more complex than the rooftops. And to date, we have not had a technology agnostic source of data that would allow us to look at a building and quickly determine where the generation potential is and how that translates into returns on investment and environmental benefits. That's what has led us to develop our analysis platform that can perform all these functions. And with this, I'll turn it over to you, Scott.
Thanks, Elisa. Okay, so I'm gonna talk a bit about how we came to our solution, how we've developed this product and platform, and kind of the reasons why, especially with some of the discussions and time we've spent in market with our key customers. I'm then gonna turn it over to Mark to show the really cool stuff, which is the technology demonstration, how these pieces come together. So in that portion, we're actually going to pull the curtain back a bit on how our technology works, show the component piece of what goes into our analysis, and actually run that and show the front-end application as well. But our solution to this opportunity, this problem, it stems from our experience as, in the energy consulting field. Our team has worked in about 70 countries in total overseas, doing everything from large-scale renewables to other types of energy projects, building projects, these types of things. And what we found was the key non-starter for many of these projects was having simple, cost-effective, accurate pre-screening data to understand whether a specific technology or approach made economic sense to study further. We saw the same thing as we developed into this space. We saw the same thing happen here, which is the cost today and the time and the requirements to do an analysis of vertical surfaces and understand if they make sense for the application of building integrated or architectural solar projects. It was simply cost prohibitive. If we're talking $30,000+ to look at a building and realize it's not a good candidate, it makes it really out of the reach of the end user and owner, and very simple to value engineer out. So we approach this problem as saying, hey, we believe there's a massive opportunity here to utilize this space in a more effective way, to reduce carbon emissions and do something impactful and good for the environment. But also the key part of what our software does is put it into real dollars and cents terms for the end user. Is there a feasible return on investment? Does this create a new revenue stream? What does that look like? And to provide that data at a pre-screening stage, in a very cost-effective, quick, and accurate way, to understand whether it's worth studying in full engineering feasibility. And so our solution is oh, Lisa, can you pop back to the last slide, please? Our solution is a studies as a service platform. So we've built some core technology around how do we in physical space understand the potential of all facades of a building, but the sexy part of what we're doing is the vertical space. We can do this for both existing assets, or we can do that for planned assets. We can work with design files for non-existent buildings during the concept design phase, or look at existing assets, be they for adaptive reuse that are planned for reclad or just run-of-the-mill existing buildings. And what we produce from this platform is a simple, easy to understand report that a user can see the key points, actionable data, have it in a way they can digest really easily. Is this exciting? Is this worth studying further? And for our users, which are architects and engineering firms, is a simple dashboard with which to create projects, to review analyses, and to be able to present that information to their end user. We also realized in spending a lot of time talking with both our clients, which are the architect and engineering firms, and the end client, the owner developer, is that we have to provide a solution beyond just the initial analysis. That's where we built a lot of our really cool core technology, but providing support, engineering support, project support, and connection to finance were also really important things. So as part of our offering as well, beyond the initial solar score study, we can provide the engineering and project support. So engineering, project engineering services, tendering and contract support, owner's engineer services, and especially connection to industry partners, the other specialists in this space that can provide the end-to-end solution. And we provide that as a part of our package as well, so we can truly take a project from cradle to grave. What we also heard from the owner developer group is that they may have a great candidate building. So they may have a building that they're planning to build that has a great potential for using vertical surfaces for solar, architectural solar, or an existing reclad project or adaptive reuse project that has great financials. But for every reason that end user may not want to finance it. They may not be able to finance it. They may have capital restrictions. They may not be able to take advantage of the tax benefits. So for us, because we can access that data and understand if they have a feasible project, providing that connection to third-party financing and some really innovative new financing solutions is a part of our model as well. So our customers then can take this report to an end user and say, look, you have a great project, and even if you can't finance it or don't have an appetite to finance it, we can provide that as well. We can provide connection to firms that are interested in that. So we really take a holistic look at how we go from initial analysis using our technology and our platform through getting a project done and supporting it at every step of the way. This is a slide I love. It shows just visually where we fit along the project continuum as far as what our offerings are. So in the initial design concept phase, verification, bankability, that's where our SolarScore product fits. And really important to note that that's really where the key inputs during entitlements, during project concept, as far as approval of BIPV has to sit, and access to really cost-effective, accurate, and fast data at those stages is what's going to make or break the installation of an architectural solar project. We realize that a software and a solution like we've developed and that we're launching is a key catalyst to getting more of these projects built. In the engineering phase, through either our team and our engineers or through our engineering partners, relationships that we've developed with some of the largest engineering firms in the world, to provide really holistic front-to-back support through construction, through project commissioning and completion. Industry partners that we have through the construction phases, and of course in the final stage, connection to finance to build a project, and eventual monitoring and reporting as well. So truly taking a holistic look at a project from the initial study through to final commissioning operations. And so I'm going to flip it over to Mark here in a moment to start to walk us through the tech demo. But just to frame it, there are some components certainly that we're going to show today that happen in the background of our software. We're going to do our best to visually represent those and show how things work. Some are very cool. Some are, some are in the background that are kind of in our technology. But to give a high level, there's about 7 steps that go into a typical analysis at the SolarScore level. The blue boxes here represent where a customer, a user interacts with the tool, and the orange is kind of what's happening in the background. So really simply, Mark's going to take us through users creating a new analysis and providing either a design file. I'll let him speak to the fact that we can either work from existing assets through a file that we create, or with a design file in various design file formats. To do that, our software creating a context model through an engine that we've developed called Bimmer, which allows us to do shading analysis and various types of things that have to go into looking at vertical surfaces. SolarScore and our software combining this context model in a design file and cladding the building. So Mark will show us how we can either manually clad a building on specific surfaces to analyze for solar, or use our algorithm to automatically clad a building and put those representative products on a building so we can model the potential. He'll take us through what comes out of our technical assessment or technical analysis, our economic analysis, and our GHG reduction analysis, and actually show us the outputs of the report in that regard and show us what comes in the report. And he'll also demonstrate what the customer front end looks like as far as being able to access that data, see it at a project level, at a summary level, download the report, and interact with the data in that way. And so with that and kind of teeing Mark up, I'm going to flip it to him to take us through these 7 steps.
Thanks, Scott. Okay, good afternoon, everyone. I'm just going to share my screen here and see if I can take you through this. So, as Scott mentioned, the first thing I'll show you is how this works. So, basically, what we have is a portal that's designed for the users to log in, and a client would see a screen something like this. They would enter project details onto this screen and provide some information for us to work with in terms of which sort of type of building they're looking for, some building details, and then they would run that through our software and system. And if I can just jump back here to a live example, I can just show you here. Here's an example of our portal right now. We've got, you can see on the top, we've got a couple of recent projects here. One is our Empire State Building project that I'll show you some slides on that we've used for a number of demos in the past. And we did another one here for Wells Fargo Center in California, which is in Sacramento. And you can see here, we've basically got a project dashboard that allows us access to these various projects. And this is the way your projects would be stored online within the portal as a client. If you click on the new project button here, what happens is you go and you enter project details. In this case, we could enter a project name. I suppose in this case, we'll just call it a demo project. A client name, in this case, we could put something like AIA, and a project location. And in this sense, what we would do is we would just enter a specific address, or in this case, if we wanted to enter a building name of an iconic building, sorry, you can enter something like the Empire State Building and select it from a list. Then we would enter a project type for the office, or if it's residential construction, building size, currency in US dollars. In this case, we'll just give a sample building size here, 1,000 square feet. If we have energy usage, this can be used to calculate other things like HVAC savings, which are done in certain scenarios and not in others, depending on whether or not we're doing a marginal cost analysis or comparing to retrofit replacement of low energy efficient windows, other such things. And we can just put in some energy usage figure here to continue. Did I miss something?
Sorry, Mark, you just have to remove the comma from the 500,000.
Sorry, thanks, Jag. Okay. And then in this case, we would generate a context model with the software here. And of course, we're just going through a simplified look at this, and I'll show you what that looks like. And eventually then we would go forward, upload a model file, which I'll explain to you a little bit more about. Scott touched on it earlier. And also we could upload an image file as well to accompany the report, which could be a rendering of a new structure or a picture of an existing building. So if I can flip back here for a minute, I'm sorry, I'm going to be flipping back and forth to slides a little bit here between slides and live demo just to stay on track. But now we're at step 2, which is how it works. So this is an image that's generated by our context modeling software, Bimmer, that Scott mentioned. And Bimmer is a piece of software that we had to create as a module in order to develop our overall solar score reporting platform. Bimmer creates context models. We use it primarily for looking at shading from surrounding structures when we calculate the solar power production of a given building. In this case, you can see it's a model of New York City with the Empire State Building there prominently displayed on the just to the right of the screen, or right of the center. And basically what happens is you can use Bimmer to create your context models of surrounding buildings, but you can also use it to create the actual model of the building that you're using if you're going to do, let's say, a reclad. If you're going to do a new design, then what you would do is upload your own design in a design format. Right now we're accepting SketchUp and GBXML, which I'll go into more, and eventually have support for other file formats like IFC and Revit, among others. And our software will merge those two things together with the new design file and the context model to create, calculate the shading. But I'll just give you an example of how Bimmer works now so you can see that. So again, apologies for switching back and forth. So I'll just load up Bimmer here. And Bimmer is actually a standalone product now that we've developed, and we're giving it away for free right now during this whole COVID-19 crisis. Originally, we were going to launch it for a fee, and it'll be a fee for month service, but in light of what everybody's going through, we thought, what could we do to help? And although it's probably not a lot, and it's not necessarily directly related to COVID, we do know that a lot of organizations are going through a lot these days, and we thought if we can save them some time or some money to try and build context models and that helps them, well, that's what we can do. And like I said, it's not a lot, but we're trying. So if you go to try it now, and by the way, we'll send a link to everybody who attends the webinar afterwards so that they can go in and try Bimmer for themselves. So here within Bimmer, we would enter a search address similar to the field you just saw in the other portal. In this case, again, I might as well just use the Empire State Building. And you'll see that it gives you longitude and latitude coordinates, zip code. And then all we have to really give it is a radius in meters from the building so that we can calculate how many surrounding buildings we're going to look at. In this case, we'll hit preview, and you can see that it's generating it. And within this pane here, you'll see overlaid on top of the map, a general context model preview. Now, New York, obviously very dense city in terms of population density and the number of buildings. And in terms of software, that translates into lots of polygons. So it takes a little bit longer to generate this model than other ones, but you can still see it's relatively quick to get the preview up. We allow for a radius right now of up to 1,500 meters from a building. And it works in almost all cases. In densely populated areas, you might only get 1,000, but we're working on expanding that for the future. But generally speaking, it's more than enough to calculate the shading that we're looking at. So you can see here, as I mentioned earlier, we can calculate GBXML files or prepare SketchUp files. In this case, we'll do a SketchUp file. And GBXML, if you're not familiar, is the Green Buildings XML standard file format, which has a lot of information that can be used in leading software platforms like NREL's Open Studio and other things to calculate various types of building energy efficiency statistics and such things. And of course, SketchUp, which I'm sure most of you are familiar with. So you just notice there, that's the duration it took to download the file. Again, quite a bit longer than it would take for a less densely populated area, but so there it is. So then what we can do is I'll go into SketchUp and I'll show you that file. Again, apologize for the switching, but if I go into here and I'll pull up my downloads, you can see this is the file here that was just generated today at 2:24. I'm in Canada right now, so that's our time right here, which you can see. And if I just open this, it should pull it in SketchUp. And you'll be able to see the context model we just generated with basically just an address and a radius. And there it is. So, and if I just zoom this out, I'll probably make some sense of it. And just grab it here. And there's our friend, the Empire State Building, with a number of surrounding structures, as you can see. So as I mentioned, we use this software to generate the context model so that we can work on the shading from adjacent structures. But of course, Bimmer can be used for other purposes as well. If you're looking at potentially traffic planning or green space or security, these sorts of things, you can use Bimmer for other purposes as well. And we encourage you all to use that for free right now and try it out. And would really appreciate any feedback you can give us on that. So again, if you're going to design a new building, and let's say you're going to knock down the Empire State Building and build a new building, doubt that's going to happen. But if you were, you could upload a design file, and with the geometric or geographic coordinates of that, our software would merge the two files together. It would remove the Empire State Building and just leave a footprint on the ground in a different color, so you could see where it was removed. And it would overlay the design file of the new building on top of that. Within that new design file, you would be able to add windows and other things and flag them as BIPV claddable using a SketchUp material that we import into SketchUp, and something we'll set up for our clients automatically so it happens. And otherwise within here, we can use this software to go in and actually add claddable surfaces if we want to apply algorithms to clad those surfaces instead of uploading design files. So what we would do in this particular instance is if we wanted to clad one of these facades of the Empire State Building with a material, we would simply right-click on it, get the entity info for that side of the building, drop into this, and you see we have a SolarSkyrise cladded material here. We would then proceed to paint different components of the building with these materials, and this would next step software, which is behind the curtain, how to apply BIPV to this in our model, calculate the shading for these sorts of things, and then eventually get us a solar score report. But that's effectively how it works within SketchUp. So I'll just get out of SketchUp for now and return back to the presentation. So moving right along, we would go into step 3. And this is where, like I said, that file then would be loaded into our software with a claddable area of the building. And then we would run that through the engine to do the economic, technical, and environmental calculations for a particular solar score report. What'll happen then is here's some screenshots of the platform. You can see there's a heat map there with solar irradiance and shading calculated for different target points of the building. And you get a bunch of, this is an excerpt from Solar Score report, so I'll just sort of take you through it for the Empire State Building. It was a marginal cost analysis, and basically what it did here is, this is an example of the technical component of the report itself. And give you a number of statistics about the area of the building that's being cladded, portion of building energy offset by solar, the annual energy production of the system, and of course a monthly curve of how much energy would be produced from the system over a course of a given year. In this case, we would be using a high transparency panel, which has obviously a lower efficiency per square footage for power generation. But there's also things like lower transparency panels that are more opaque, that have higher per square foot or per square meter energy generation potential. And also rooftop panels, of course, which are completely opaque, and they have the best as well. So moving through this, I'll just take you to the next screen. And this is a look at some of the, skip the screen. This is a look at the economic analysis of the particular project. So we look at the cost of the system. In this case, it's a marginal cost analysis. We look at the value of that energy produced, and that's related directly to the tariffs in the region or city or municipality or area that the structure is actually situated. So it's all localized. We'll look at rates of return and projected values of increase in the value of the building based on the fact that solar is going to be implemented. So from a financial perspective, we explain how justifiable this project is across a number of different dimensions. And we can also look at other factors too, like the HVAC benefits of the BIPV related windows, if they're going to be windows. In relation to other types of windows, like say, for example, a standard single glazed or more commonly a double glazed window, if there's an additional benefit there, which factors into the analysis. Look at the expected life cycle costs of the system itself in terms of operations and maintenance, system degradation over the years in terms of the panels and the expected life of the system, as well as the expected tariff rates based on where we think those are going to go in relation to a locked-in energy price that somebody would be receiving based on the fact that they've installed solar. Moving along, this is a sustainability related analysis where we really look at carbon offsets and try and relate that back to specific measures that I'm sure you're quite familiar with in terms of things like homes powered for a year or cars removed from the road. talk about some of the benefits, softer side of things, in terms of the fact that the asset's differentiated and you get some better credibility as an organization from having a green-related building. And in addition to emissions, we're also looking at adding measures for things like embodied carbon in terms of cradle to gate for in the future for manufacturers who are able to provide that information for their panels. And then we get back to the next step here, which is the dashboard itself. But before I take you into this, this is just a sort of a summary of the report. It's how it sits within the dashboard, but I'll take you back to the portal first and show you one more shot of how that is. So if I were to go here, I can pick, in this case, I'll just pick the Wells Fargo one, I suppose. And what this will give you here when it loads is a look at just a summary level of the information that's provided within the report. So a lot of the things I took you through before in terms of the technical information, the economic information, and the sustainability related information is provided in a very simple, easy to use dashboard. And this provides access to a repository of any design files that have been uploaded, in this case, the SketchUp model, a photo that goes and accompanies the report. And you can also have a report version history. As I'm sure you're all quite used to, there's a number of versions you might go through over the life of a given project as it goes from conception to reality. So in this case, we allow people to store various versions of those reports. And if we were to just look at one of these, we can just pull it up here. And I'm going to have to just unblock my pop-up, but my Zoom bar is in the way. So if you can just excuse me for a second, I'll move it. And there it is. And this would be a look at the building report for the Wells Fargo Center. Marginal cost analysis with the big items here and sort of in the masthead of the report, payback period, energy produced by solar installation, size of the system, a lot of the, the main things that are the highlights of the report. A picture here of the building itself as it sits today, what it looks like with one of the facades cladded with some BIPV related windows, and details like from I showed you in the presentation before on the technical, economic, and green resilience analysis. And finally, on the last page, we talk about things here like the system life, production degradation factor, and all the assumptions basically and interpretation guidelines that go into the production of one of these reports. Of course, as I mentioned earlier, these things are displayed within the dashboard here, and we can toggle between different projects, whether it is an existing project, a new project, or a number of different projects that are within the platform itself. And basically, I think that is about it. I'll go back to presentation. And yeah, that's it. So with that, what I'd like to do is just open the floor for any sorts of questions. I see there's a few in the chat queue that we'll be happy to speak to live. And please, everything's open for discussion. Thank you.
Thank you. That was excellent. This is Rona. So before we go into the Q&A that I think you've all, at least our panel has read it, the attendees should be able to see the Q&A too. There's one question answered, which I'll just read. Is there a building height that doesn't make sense to incorporate vertical solar potential? And Tom replies, it's a vertical wall space that's important. So a low but large footprint can still have a lot of wall space to install BIPV. As long as the vertical space is mostly unshaded, it will work well with BIPV. There's also a question in the chat room. We're interested to see if the BIMR tool can also be leveraged for natural ventilation estimating. So does someone want to take that before we go into the list of questions in Q&A?
Mark, you're on mute.
Yeah, hi. I can try to take that one, but I think what I'd rather do, like to give a really good answer, is to have a discussion with ourselves and a couple of our other experts. Generally speaking, I suppose it depends. BIMR is designed right now to look at the external facades of buildings. So in terms of wind gusting, things like that, it could be modeled. It's not something that our organization does or is overly familiar with. We have a sort of limited experience in this regard. I'm probably not the best person to answer that question, but I may be one of the better people on the call to address it at all, unless, Tom, you have anything to add to that. It's not something we currently do today, but it's if we exchange contact details later on, I could have a discussion with Tom and some of our other people and determine if there's something we can do in that path. But I definitely today, that's not something we look at.
Right. Let's just park that. The man inquiring has put in a response, but let's go on to the questions that you've all marked for each other, starting with the first one about software analyzing energy potential. Mark, you were going to take that.
Yes, sorry, I'm just going to have to open it again so I can see it.
I could read it.
Sure, if you wouldn't mind.
How does the software analyze energy potential? Is there any data about accuracy of results?
Okay, so the way the software works is it considers the technical power production, and this is the really foundation of how it works. It looks at standard weather meteorological data in terms of solar irradiance. It calculates the solar power production of the rays using ray tracing that are hitting a given surface of a building. It looks at the reflection of that off of surrounding structures, including the ground and adjacent structures. And it also looks at the impact of shading and how that has an impact upon the power production for a given year. The system life cycle and everything is factored into this in addition to degradation. And in terms of the level of accuracy, it's an excellent question. And the answer, and again, I can ask Tom what he thinks about it, but at the end of the day, the accuracy right now is, we believe it's excellent, but in order to really assess the accuracy of any given installation, we need to have more installations in order to see at the end of the day if we hit the mark. So right now we're undertaking some research projects with a number of different organizations and educational institutions to try and go from cradle to grave for an existing project from concept to go live and commissioning. And then we will be evaluating the accuracy of the software and improving, assuming it needs improving, the predictive capabilities of the software through some AI algorithms that are currently being developed by our firm. But unfortunately, in order to know with certainty how good the predictive capabilities of the software are, we need more installations and we need more data. And we only have a couple that we've looked at so far. So I would be remiss to say that we could assign an exact number to that answer today.
Rona, you're on mute.
Sorry, it's a slight hazard of this tool. My apology. So there was another question that I've been writing them down that doesn't seem to be in the Q&A right now. Maybe it's been removed, but I thought it was a really good question. So I'm going to read it. Building height. Is there a building height that doesn't make sense for vertical solar potential?
Is that the question? Is that the one that Tom? Is that the one that Tom just spoke to?
Not exactly.
Yes, I sort of answered that.
Oh, okay. Okay. I mistook that. All right, then going on. How does the software consider installation and life cycle in the return on investment calcs?
I can take that. So effectively, the software looks at an average annual system life based on the life of the panels and associated apparatus that's installed with the system. In the case of the reports that we put up there was a 30-year system life assumed with a degradation factor for the panels every year that was built in. Operations and maintenance costs are assumed as well for the life cycle of the project. And yeah, Tom, anything to add to that?
Yes, typically not all parts are replaced at the same time. Inverters tend to fail before the panels, probably between 15 and 20 years. So that's included in the analysis that you'd probably have one inverter replacement in the 30-year lifespan of the system. So all those kinds of things are also, any capital expenditures later on are included.
Great, thank you. How does the software integrate into Revit Rhino?
Yeah, I can take up this answer. I am the chief software architect here at SolarSkyrise. Just to introduce myself. Currently, we only support GB, XML, and SketchUp files, as mentioned by Mark, but we already have our development team looking into Revit, ArchiCAD, Rhino, and a few other tools that not only could we support the file formats, but these software tools also have the ability to have plugins. So we're looking into having a plugin where you could directly send your model directly to your account and create the project or send a new revision directly through the tools like that. But currently we do not support it.
Jag, this is Scott, one thing I'd mention on that point is that we have worked with those file types. So within our team, we're able to utilize those file types to make them readable and usable within our software. So although our software doesn't natively connect to those and use those file types currently, and we're exploring that now, within our team, if that's a standard file type for a user, we can take and modify those to work within our software. So there's a solution there.
That's correct. And there's also ways to convert those file types from into other files that'll work with our platform today. For example, GBXML files can be exported from Revit and other sources, and SketchUp files, of course, can be created and imported into other sources too. So there's right now that we're still working with a bit of conversion in order to do this, but in the future, our intent is to support numerous other file types, including the industry standard ones like Revit and Bentley and ArchiCAD as well.
Thank you. Does BIMR plan on incorporating grading? Elisa?
I've actually raised my hand here by mistake. I'm going to send this question off to either Mark or Jag. One of you guys want to pick it up? Does BIMR plan on incorporating grading?
Mark, you want to pick up on this?
Yeah, at this particular point in time, the answer is no, because it's just our first release of BIMR. In the future, it's something we can look at if the demand it comes from the community. So yeah, again, we're still, like I said, it's first release of BIMR, so we're excited to get feedback on it. And if that's something that people want, then that's definitely something we can look at putting in.
We had a question answered in the chat. If you access it, website access to the BIMR tool to test out, and Elisa posted www.bimr.io. What's IO? Just asking. I haven't seen that before.
Jag?
Oh.
It's a top level domain that's just popular in the tech community.
I just hadn't seen it. Someone notes, if you need a quick tutorial on how to use BIMR, do not hesitate to reach out. So you have the names of the panelists, and they're very knowledgeable, and it seems like an excellent technical application. You went through the economics quickly, but I guess I would ask, in terms of return on investment, that sometimes my experience was that sometimes the owners don't want the public, unless it's a public owner, they don't want the public to know how much they invested. But in terms of the return on investment, I'm sure that some of your clients wanted a quick return on investment. So could someone, I know we had one question about life cycle and return on investment calcs, but what is the type of return on investment term that might be possible for buildings larger or smaller?
I'll jump in and take this one. And Jordan, we have our head of financial modeling on the phone, so if I get into the weeds, I'll flip it to him. But largely, it really depends on the technical characteristics of the project. So if the project is unshaded, it gets more sun. If it's able to use more effective technologies, higher efficiency technologies. If in the region the project's in, the prevailing cost of power is higher. These all really play in really importantly into the economics of the project. We do essentially a project lifecycle net present value analysis of all the different revenue streams from a project, all the various cost streams, so ongoing operations, production degradation, all of those things over the life of the project. We also our tool can look at a variety of different debt equity ratios, so we're able to model out based on the real economics what the return is going to be. So it depends too on if we're looking at for a new building or a retrofit, reclad, or an adaptive use, where new products will be used either way. We can do a marginal cost analysis. So what is the additional cost of solar? What will it be above and beyond a traditional construction material? We can also do it at full cost. So what if we were able to pull off the existing materials, be they curtain wall or traditional building materials, and put up solar? So it really depends. It's largely dependent on the type of project, on the location of the project and what surrounds it, also prevailing tariffs and the type of application, be it retrofit or new build. As far as ranges, we've seen everything ranging from, the projects we showed during the demonstration, when we looked at specific areas of, in the case of the Empire State Building, the south side of the building, on a marginal cost basis, the rate of return was approaching 50%. So from an investment perspective, the way that we look at this is, these are not new solar technologies. The application to the vertical surfaces in architectural products, that's the innovation, but the key underlying solar technology is 30 years old. So these products will produce power for a known project life. Buildings will use the energy. So the project returns and lifetime we look at as a very blue chip investment, that the building's going to need power. It's going to be installed for a certain period of time. And that will be essentially a guaranteed return. So when we look at these projects, they can vary from unfeasible if the building is highly shaded and we're looking at a north side in the northern hemisphere. It's likely not going to be a feasible project. But we've seen many cases where the rate of return is 30+% on that investment. Project payback periods, we've seen everything sub 10 years, sub 8 years, in certain cases even sub 5 years, all the way up to, in cases where it doesn't make feasible sense, 20+ year payback. So it really depends on the project, but our software is able to take all of those into account. And what we really try to be and what we adhere to is agnostic. So we want to be a provider of accurate data. We're not affiliated with any specific makers of these panels. So we're able to look at what's available on the market, understand as new products come to market, as they're commercialized, as things change, truly what the potential of vertical surfaces are. So that's, Jordan, jump in if I miss anything, but from a high level, we do a really detailed net present value analysis of all the various cost and revenue streams from a project.
Thank you. Jordan, we're going to add something? Oh, you have to unmute. Thank you.
Sorry, I think Scott gave a pretty comprehensive answer. The one thing that I will add is that the business case can change on the individual building based on the size of the installation. So it may not be economic to clad the entire building, but what our software can do is we can optimize the project for a particular rate of return. So we can target maybe a particular portion of the building, such as the south face only.
That's interesting. What's the largest building in which this has been application has been used that you know of? The Empire State Building is a very large building, so it's a provocative. If it's a real project, it's a provocative and certainly interesting example. Plus, the building is from the 30s, so it's almost 100 years old.
Yeah, a good example would be a building called The Edge in Amsterdam. It's a well-known net zero building in Amsterdam. So that would be a good example to look at.
Great. I don't see any other new questions. We have a few minutes. It's really been informative. It's not an application that I was aware of, and it's certainly, you're all very knowledgeable source experts. Is there anything else you'd like to add in closing?
Well, there's actually there are a number of new questions.
I'm
not
not seeing them here. So, Hillary, it isn't seeming to come up in my display.
Oh, Elisa, if you want to proctor the last questions that came in, go for it.
Right. So there is a question that just came in. As a rule of thumb, what's the decrease in solar panel efficacy from rooftop to vertical in terms of output? Mark or Tom, would you like to take this one?
Could you repeat the question, Lisa?
As a rule of thumb, what's the decrease in solar panel efficiency from roof to vertical in terms of output?
About 30 to 40%.
Okay, there is another question for you, Tom, I think. Is there an ability for a difference in efficiency to be accounted for between microinverters versus centralized inverters?
Yes, you can do that into the loss evaluation of the power production. That assumes a certain percentage from the rated of the PV panel to the AC bus inside the building. There'll be a certain loss within where the panel produces the power to where it gets used in the building, and different technologies will have different amount of power loss. String inverter versus microinverters, etc., and how you use that. So you can take that into account by adjusting those numbers.
There's something I'd like to add to that as well. The first level of analysis that we do, that we've demonstrated today, is what we call like a solar score analysis. And this is effectively a pre-feasibility level analysis that people are intended to use to ascertain, first of all, whether or not to proceed down the path of pursuing a given project, or also to shortlist among different buildings or premises for which projects they want to proceed with. Having said that, I mentioned earlier, the designs for those particular projects will change probably numerous times from concept to reality. But in addition to that, as the project is given the green light to proceed, a higher level of detail will be required. So we just demonstrated the first level of analysis here, which again gives you a higher level of a higher margin of error in terms of determining what to move forward with. But after this, we also have a product which is our solar spec analysis, which goes into much more deeper level analysis about the actual design, physical verifications of the premise itself and the surrounding structures, review of, for existing retrofits, a review of energy usage of a given structure, and a lot more back and forth. So we're not advocating or trying to pretend that one report could take you all the way from concept through to commissioning. What we're trying to do is get a report to get people to start moving forward with this and building it into their projects. But then, of course, once the green light is given to go ahead, more work is required for verification. Now, we provide that work, and we have engineering partners that support us in that process, but we do support all of these other technologies. There was a question I just answered here about whether or not different levels of transparency for glass and glazing can be considered, and the answer is yes. We can look at different modules, we can look at different layouts, we can look at optimizing all of those things. But again, today I just want to emphasize what we demonstrated was the first level of this platform, which is effectively a pre-feasibility level analysis.
Great. Are there any other questions?
There's a few questions for me that I feel like I'm just going to answer, if that's okay.
Why don't you do that, please? Thank you.
Sure. Yeah. So one of the first questions was what kind of dimensional accuracies are in BIMR, plus minus 10 feet, 50 feet. We're guessing it leverages Google Map 3D data or equal. What we actually use is a combination of private and public data. So public data would include things like the Google Maps 3D data, OpenStreetMap data, government supplied building information, and also multiple sources of a LiDAR data supplied through things like NASA and things like that, and all conglomerate into one resource database that we use that we pull in from. So regarding the accuracy, it's really tough to say, to be completely honest, because when you get into some of the more rural areas, or you get into countries that don't have I guess like a large tech scene there, you're not going to get, because a lot of these sources are publicly sourced, you're not going to get a large data set from those countries. And we try our best to create a model in those situations that we can. But if you go to any major city in United States, Canada, or any of the major first world countries, you're going to get really great data that is very accurate and is frequently updated because, like I said, it is publicly sourced and also privately sourced.
And just to add to that, I guess what I'd like to say too is there is no perfectly accurate data source online anywhere. And even the best data sources in the world are still subject to the fact that the built landscape is constantly changing. But notwithstanding that, even some of the best sources of data that are available for purchase today we still find that they're only as good as they are. And we feel very confident that we're leveraging the best available sources of data that we can find online. But we'll also look at BIMR, at least in the context of BIMR, as a starting point. So is it 100% accurate? Absolutely not. But could it save architecture firms and other people a lot of time in terms of doing context modeling versus in terms of whether or not they have to scrape that data themselves online or go get it other sources? Absolutely it can. And again, depending on the level of accuracy that's required from anybody who's using BIMR for those sorts of purposes, if they're looking for a general level of accuracy, it's going to be great. And if they're looking for a perfect level of accuracy, the only way to do that is to get on the ground and measure. So we feel that BIMR is a great starting point in that regard. And it's well, right now it's free, so it's a great price, I think. But even when with the pricing model for it, it's actually still quite low. We believe it can shortcut a lot of the work for people who are going to use it for those purposes, and then supplement it or augment it with verification if a higher level of accuracy is required. And that's what the business case for BIMR is built upon. Sorry, Jack, back to you for the other questions.
No problem. So another question I got, I'm actually going to answer two in one because they kind of go together, is does the solar score include just direct irradiance using the BIMR tool, or does it also estimate reflected irradiance as well? And there was another question that said, regarding the software analysis, sounds like MIT's radiance tool is the backend ray tracer. We are not using MIT's radiance tool for ray tracing, but we are using OpenGL, like open source tools, including OpenGL's open ray tracing tool to do ray tracing, live ray tracing, which, to go back to the initial question, real-time ray tracing allows you to, yes, get all reflected irradiance as well as not just direct. It factors in everything. The panels themselves we have the details about how much would be reflected off of them, and then that is factored into the calculations.
Thanks, Jag. I'll jump in here. There's a question to answer on the financing and the structures. So the question is, what opportunity or challenge exists for BIPV windows to be financed by a third-party financiers, example, tax equity investors, do you see for the traditional commercial utility PPAs? And so we've been in discussions with a number of capital partners who've done a lot in the space of third-party roof leasing for solar, and they're very excited about this space. It essentially unlocks an entire new axis of investment potential for them. There are certainly a couple new things to be considered when looking at vertical space that's built directly into an asset versus utilized on a rooftop. We're in those discussions now to find solutions there, but there's certainly been from our meetings, a lot of meetings in market in California, New York, and some of these key first markets, which is that the ownership and development group has a desire for this, and that the financing and investment group also has a desire to look at this space. And we're working through the evolution of that PPA structure to look at projects like this. So it's not a completely new outlook, but there are some tweaks to be made. But there's certainly a huge amount of potential in this space, and we've got a lot of excitement on both sides around how we can bring finance to these projects.
Thank you. There may be other questions that a few others that we haven't answered, but I think we should, with 2 minutes left in the hour and people needing to move on, if we could just close. I don't know if each of you would like to just make a closing comment, and we'll thank you for sharing this unique tool, and certainly anyone can reach out to you or to AIA California at www.aiacalifornia.org. So on that note, Alicia, Scott, Mark, Tom, Jag, and Jordan, thank you very much. So I'll leave the floor to you if there's anything you'd like to say to close in the next 2 minutes.
Sure.
1 minute.
Thank you. Yeah, I'll if anyone on the team wants to say something, please jump in. But I'll speak on behalf of the team, which is we really appreciate the opportunity from AIA California to come in and do this webinar and showcase what we've been working on, the things that we think are really important as far as how do we catalyze projects in this space, and we think it's very cool, and we think there's a lot of opportunity in this space. If anyone has any additional questions, feel free to reach out. You can find us on our website. We're happy to answer in detail what we're working on and how we can work with these different user groups to provide a ton of value. We're open, we're happy to share, and we look forward to hearing more and providing as much value to the architectural community as we possibly can.